You got a bad flu last winter. Your body ached, your temperature spiked to 103, and you spent 3 days convinced you were dying. And then you recovered, and for about a week you felt genuinely invincible. Your immune system had fought something off, you had survived. You were tough. There's an animal living right now in the moss on your roof that has survived being frozen to 1 degree above the coldest temperature physically possible in the universe, boiled at temperatures that would cook you like a shrimp, blasted with radiation 500 times the dose that would kill you within days, shot into the open vacuum of space with zero protection and completely dried out until there was not a single molecule of water left anywhere in its body. And then, decades later, had water added back and simply woke up and walked away. It has survived all 5 of Earth's mass extinctions. It was alive before the dinosaurs existed, and it is 0.5 millimeter long. You have walked past millions of them today without noticing. Is it some deep-sea creature with armor plating? Does it have antifreeze in its blood? Can something really survive actual outer space? And what does surviving its own death actually mean? Because that's not a metaphor. That's exactly what this animal does. Here's the thing about extreme survival that your brain gets wrong immediately. When you hear that phrase, you picture something tough, armored, shielded. You think of polar bears with thick fur, camels storing water in their humps, deep sea fish with reinforced bodies built to handle pressure. The logic is dangerous environment, therefore protective adaptation. Something between the animal and the danger. That logic makes sense for almost every animal on Earth, but it doesn't apply here. The tardigrade, that's the scientific name, though most people know it as the water bears, does not protect itself from extreme conditions. It doesn't fight them. It doesn't shield against them. It does something far stranger. It stops being alive. Every single measurable sign of life drops to zero. No heartbeat, no metabolism, no cellular activity, no breathing, nothing. Scientists have a term for this state, cryptobiosis, meaning hidden life. But that name is almost too gentle for what's actually happening, which is that by every clinical definition medicine uses to determine whether something is alive, the tardigrade is dead, and then it comes back, which means our definition of dead has a problem. But here's where it gets insane. The mechanism behind this is one of the strangest things in all of biology, and it starts with something you probably have in your kitchen cabinet. When a tardigrade senses it's drying out, it begins producing a sugar called trehalose. And this sugar does something that should not be possible. It physically replaces water, molecule by molecule, inside every single cell in the animal's body. Your cells need water to hold their shape. Proteins fold correctly because of water, membranes stay intact because of water. Every chemical reaction that keeps you alive happens in water. Take the water away and everything collapses. Proteins crumple, membranes rupture, DNA breaks apart. You die in minutes. But trehalose binds to the exact same spots inside the cell that water normally binds to. The proteins hold their shape, the membranes stay sealed, and then here's where your biology completely fails you. Those trehalose molecules solidify. They turn into a glass, not glass like a window, a biological glass, a rigid, amorphous solid that locks every structure inside every cell into exactly the position it was in, like everything got frozen mid-sentence and preserved perfectly. No movement, no decay, no chemistry, no time effectively. The animal is not dried out. It has been converted into a living glass sculpture, waiting for water to dissolve the glass and let it pick up exactly where it left off. That is why it can survive 300 degrees Fahrenheit heat, hotter than a kitchen oven, without damage. You can't cook something that has no liquid inside it. That's why it survives 1 degree above absolute zero. The coldest temperature physics allows to exist. You can't freeze something that is already solid. One mechanism, multiple impossible environments covered simultaneously. That's not even the most unsettling part. Separately, tardigrades have a protein in their cells called Dsup, short for damage suppressor. This protein physically wraps itself around the tardigrade's DNA like a full-body shield and blocks radiation from physically touching the double helix, not repairing damage after the fact, blocking it from happening in the first place. The lethal radiation dose for a human is around 4 to 5 gray. That's the unit scientists use to measure absorbed radiation. A tardigrade survives up to 570 gray in active state. Some studies in tune state suggest tolerance above 6,000 gray. That's somewhere between 100 and 1,500 times the amount that kills you. For comparison, the workers who died at Chernobyl absorbed doses between 6 and 16 gray. The tardigrade would have walked away. The temperature numbers alone are enough to make you feel fragile. Your core body temperature can't go above about 107 degrees Fahrenheit without your brain starting to fail. The tardigrade survives 300 degrees Fahrenheit. Your cells stop functioning and die below about -4 degrees Fahrenheit. The tardigrade survives -459 degrees Fahrenheit. That's 1 degree above absolute zero, the point at which atoms themselves nearly stop moving, the coldest anything in the universe can physically be. On pressure, the deepest point in the ocean, the Mariana Trench, sits at about 1,000 times atmospheric pressure. It would crush an unprotected human body instantly. The tardigrade survives 6,000 atmospheres, 6 times deeper than the deepest place on Earth. In 2007, the European Space Agency placed tardigrades on the outside of a satellite in open space. No container, no suit, no protection of any kind, hard vacuum, solar radiation, ultraviolet bombardment. They came back alive. You need a pressurized suit, an oxygen supply, radiation shielding, temperature regulation, and a re-entry vehicle just to leave the atmosphere for 6 minutes. The tardigrade needed nothing. The closest animal comparison is the brine shrimp, the sea monkey you might have grown in a cup as a kid. Brine shrimp can also enter a dormant state when dried out, but they only survive a fraction of the temperature and radiation extremes. They need salt water to revive, and they have never survived open space. The tardigrade beats every known animal on every single metric at the same time. The closest human parallel is freeze-dried food. We use the same basic principle of removing water to stop decay, but the food is dead. The tardigrade is the only thing on Earth that survives its own freeze-drying and then gets up and walks. Now here is where the story gets personal. This animal is not in some remote extreme environment that you'll never visit. It is everywhere you have ever been. That patch of moss on a brick wall you passed this morning, packed with tardigrades, many of them in tune state, having been there since before you were born, waiting for rain. The gutter on your roof. Tardigrades live in the thin film of water in the debris, and when it dries out in summer, they don't die, they just wait. The dried crust at the bottom of a mud puddle in your backyard, tardigrades in suspended animation, indistinguishable from dust, revivable with a splash of water. Scientists collecting soil samples in Antarctica, in the driest and coldest places on the continent, find tardigrades alive. Not fossilized, not traces, alive. They've been found at the bottom of the Mariana Trench. They've been found in glacial ice at 20,000 feet in the Himalayas. They've been found in hot springs at temperatures too high for most bacteria, living there actively without even needing to enter tune state. It was just a normal Tuesday for them. They've been found in municipal tap water in multiple cities, having survived the filtration and chemical treatment process, completely harmless, just present. In 2013, while Elon Musk was announcing the Hyperloop, Japan was testing a maglev train that floated above its track. That same year, scientists were also documenting tardigrades reviving after 30 years in a museum freezer, and one of them laid eggs that hatched. Researchers preparing samples for electron microscopes, which use beams of particles to image objects at nanoscale, have had tardigrades wake up inside the machine mid-scan. The device built to image tiny things had to stop because the tiny things started moving. There may be tardigrades alive right now in a dried-out bottle of Kraft moss in your closet. Add water and check back in 20 minutes. To be honest about this, the tardigrade is not immortal. In its normal active state, it is genuinely fragile. It eats algae and bacteria, it lives for months to a few years, and a curious child can end one with a toothpick. The tun state only kicks in under specific triggers, primarily desiccation. It doesn't automatically protect against everything in real time. These are real limits, but those limits are exactly what makes the biology scientifically useful. In 2016, researchers at the University of Tokyo took the tardigrade's Dsup gene and introduced it into cultured human cells. Those cells then showed 40% less DNA damage when exposed to X-ray radiation, 40% in human cells, from a gene belonging to a half-millimeter water bear. That's not a treatment. It's a cell culture experiment, and human applications are far off, but the direction is clear. The trehalose mechanism is already being applied to create shelf-stable vaccines that don't need refrigeration, which could transform healthcare delivery in regions without reliable cold chains. NASA is actively studying cryptobiosis as a model for protecting biological material during long-duration deep space missions. Every major avenue of that research started with someone looking at a tiny, chubby, 8-legged animal in a drop of moss water and asking how it was possible. Everything humans have built to survive, heated homes, insulated clothing, medicine, surgery, spacesuits, pressurized aircraft, exists because our bodies gave us almost no margin. We live in an extraordinarily narrow window of temperature, pressure, and radiation. Step outside that window and we die quickly. Somewhere in the moss outside your window right now, there is a tardigrade in tun state, motionless, glassed over, no heartbeat, no breath, that was alive before the pyramids were built, that has outlasted every catastrophe this planet has thrown at life for 600 million years. It is waiting for rain. It has all the time in the world.